Hello everyone, in this video I would like to introduce how can we implement the sequence control in Rockwell Brandley RSLogix 5000 or Studio 5000. And in this test I will use L32E version 20 this controller and use RSLogix 5000 this software to implement this sequence control. In this video, I will mainly introduce the sequence structure, and in the next video, I will base on this sequence structure to implement the camera keys IV2 camera trigger control. Okay, to implement the sequence control, we need to couple tags or variables. Personally, I prefer to set up one date type to organize all the tags regarding the sequence control together. So I will go to the date type, user define, right click this new data type, UD sequence control. Okay, click OK. So it will ask us to set up one structure. Okay, first one, that is one integer number that represents the different sequence step. That is an integer number that represents the different sequence step. And next, sequence conditions. So those conditions are Bool signal. Those Bool signal will be used to control move to the next step. They are Bool array, so I will name it Bool 100. Okay, they are Bool signal. Binary. Those are the sequence conditions. And then next, they are sequence step. They are still Bool sequence step. Okay, Bool. They are binary. Okay. Okay, next. And they are sequence step timer. So those timer will be used to transit from one step to the next step. That is the interval time between step to step. So this is timer. Timer, we will set timer. Okay, 128, the length. Okay, those are enough. So we set up the integer number that is represent the step number. Conditions are the condition to move to the next step, and the sequence step represents the current step. If we are at step 10, so the sequence step Bool 10 will turn on. So the step timer will be used as an interval time between the step to the next step. Okay, so we click OK. So this structure name that named UD sequence control. Okay. At here, let me create the actual tag. So from this controller tags, this edit tags, we will name the sequence demo. Okay, this is the actual sequence name. We could program multiple sequence. So this sequence will be used as a demo structure. So it named the sequence demo. And this date type, we will use the date type we just create. So that is a UD SEQ control. Okay, after create this, it will create the actual tag for one sequence. The timer, this is a one array. So for different timer, it has a ACC, EN, TT, DN here. Okay, let's go to the main task. Let me create one row routine. That routine we can name, this is the sequence demo control. And we will use the ladder logic. Okay, firstly, let me go to the main routine to call this sequence control, this routine. Type in the GSR, and then to call this subroutine, sequence demo control. Okay, let's go back to this sequence demo control, because this is the main routine, and this main routine will call other subroutines. So we will start to program the sequence control within this sequence demo control here. Firstly, let's program the equal. Go to find out the compare and find out the equal. Okay, the first step, that is a step 0. We will use this step 0 as an initial. So the source, that is the sequence number. The sequence number, we will go to find out the sequence demo, and this is a sequence number integer. When this step number equal to 0, so we will turn on that bit represent this step demo. We will control this step number 0. Okay. The step 1 will be the same. Okay. Personally, I will use the step number 1 as our initial step. We start from the step 1. When the step number equal to 1, this sequence step 1 will turn on. We will add a condition between 0 and 1 here. For example, this is a sequence start. So the sequence control start will control move to the step number 1. So we will drag a move here. Sequence number to this is target number 1. So we will create a temporary tag here. So it named the sequence start. So we will create a new tag here. Okay. When we trigger this start, it will control the sequence step go to number 1. It will jump here. When it's equal to 1, we will do something and allow this step move to the next one. When it's equal to 1, it will turn on. And here, we need a condition move to the next. So we create this, and we will add a condition here. So we will add a condition here. So condition, and this condition allows we move to the next step. So the condition we will use seq demo dot that condition. So same thing, we use number 1. So some other logic will control this sequence condition 1 turn on. And once it's turned on, it will move the next step. Okay. Sometimes we want to put a timer between the step to the next step. So I will put a timer here, which means firstly I will create another level. We will move this move to here, and I will add a timer here. To add a timer, we find out the timer here, put a TON at here. That TON, we will use the sequence demo, find out the sequence timer, and we will use the number 1. The all number 1 we see here. All those indexes, they match. So, and the condition move to the next step. We'll use this timer. So when this timer done, we will move to the next step. See, this are the condition. So once we start this sequence, we turn on. This will move to the next step. So this is the actual step start. When we add this step, so this bit will turn on. And this condition will be controlled if we move to the next step. So this condition will be used to control this step move to the next step. Okay, so in actual case, we will put another branch here and another branch. We will put couple conditions at here and control this step number condition here. Once we use this sequence structure move to the actual application, we will put a couple conditions here. Those conditions will be used to control this condition turn on. And once this condition turn on, after this timer expired, so we will move to the next step. And because now I'm demonstrating this structure program, so I will temporarily delete this line. Okay. And the timer, I will set 2000 milliseconds, 2 seconds. And next step, we will move to the step 2. Personally, I will prefer our step number that is 5. That means we start at 1. And next step, I will use the number 5. And after the number 5, I will use the number 10, 15, 20, 25 using this way. That allows us to leave some spare number there in case when this structure moves to the actual case, or if you already programmed this sequence structure for your application, and one day if customer asks you to add some additional step between one step to another step, so you still have a full step as a spare. So that's why personally I would like to use 5 as a step number. Next step, I will move number 5. Next step, copy, we paste. So next step, when it's equal to 5, this sequence step number is equal to 5. And condition, we will 5. Timer, we will still use 5 here. And once this number 5 timer expires, we move to number 10. And then the same thing, this condition signal will be used to control from the step 5, move to the step 10. Okay, next step, that is a step 10. Okay, we click copy and paste. So next step, that is step 10. So this bool signal, that is the 10. 10. 10. So next step, we will move to 15. Okay, this is step 10. So let's move to the next, step 20. So after the 20, we will move to 25. Okay, next step, you could program move to the 25. And in my case, I will allow this sequence stop here. So I will move to 0. That basically finish this sequence. So we will leave a couple steps as a structure, as a demonstration structure for this sequence control. That means after step by step is move here. So this is the end of this sequence. It will move to the step 0. And once it's equal to 0, it will reach this line. So at here, we can use this way, add a condition here. So that means once we finish this cycle, it will turn on for this bit. So once it's turned on, it's waiting for the next trigger to start a new sequence from this step 1. And now basically we finish this sequence structure. Another thing I would like to program, that is the timeout. For example, if this sequence moves step by step, and by some reason, for example, if this sequence is at number 10, by some reason, this condition 10 cannot be turned on. So your sequence will be stuck here. How we can allow this sequence to recover, to reset to 0, to start from the beginning again? So I will program like this way. Use the last line. And this time, let's add a new run. This time, I will use not equal. Let's move to not equal. Compare, not equal. And if this sequence not equal to 0 after a timer, for example, after this timer, and at here, this timer, we could use this sequence timer 0. We could use this sequence step timer 0. After this timer, for example, 10 seconds, we can put 10 seconds. And after this timer done, so we can force move to 0. Okay. Parallel logic. And after this timer expired, and then we move to 0. So meantime, we can type in a comments here. Recover the sequence if the step stuck for 10 seconds. So recover the sequence if the step starts for 10 seconds. If this step number not equal to 0 after 10 seconds, it will force this step number go back to 0. Once it's go back to 0, so we are waiting for the new cycle start. Another thing, sometimes if this sequence start continues on, so we will find this sequence will run again and again. Normally, we will use another bit. Another bit means sequence done. For example, that means when we start, that sequence done signal, sequence complete signal, sequence complete. Okay. So when we start this sequence, we want this complete signal is off. And at the end of this sequence here, so when the sequence number equal to 20, and especially this step number 20 turned on, so at here, we could set that sequence step. For example, we could add here. So let's add one line. That means when this timer turn on, we can set that sequence complete signal. Once we reach at the end of this sequence, we can set it on. The sequence depends on the length of the sequence. Sometimes your sequence maybe reach 80. So at the end of this 80, we could turn on this sequence complete. And when we can reset this sequence complete, basically most of the cases we will use no parts or cell empty or machine empty to reset this sequence. That means once you use this sequence, finish your part assembling or finish your automatic sequence, and once you release the part, the sensor present turn off. So use that signal to reset this sequence complete. So we can program this line and to reset this sequence complete here. And so we'll use this OTU to reset this sequence complete. So we can use this part present. So we use the reversed logic. That means if the part present is gone, so we will reset this sequence complete. This part present could be also used as our initial status. Let's firstly create this tag. So the part present, right? I will move to the top. This part present, in actual case, this part present will be connected to the actual input, the signal input signal. Okay, till here, we basically finished this sequence structure. Let me download and let me demonstrate how this sequence move. Okay, let's compile and no error. And no error, let me download. And I'm using L32E compact logic. So let me download. Okay, download, start. Our main routine uses this GSR code, this sequence demo control. And in this sequence demo control, we programmed one demonstration sequence structure here. Okay, now this sequence is at 0, so this bit turn on. This bit turn on is waiting for the part present turn on and waiting for the sequence start signal. And by default, the sequence complete signal is off. Now let's demonstrate this part present. We load the part in the cell or in the machine. Most of the cases, the sequence start will be used to connect to a pump button. Once we pump the button or press the start button, so this sequence will start. From testing wheel, because we are going to test this sequence, 10 seconds might too short. So I will set 100 seconds here. So I will set I will write 100 seconds as a default. 100 seconds. Okay, let's move to the top. Now the sequence number is at 0. We are at the initial status. Now I will turn this part present on to demonstrate we load the part in the cell. Okay, now the sequence is waiting for this sequence start. So I will start the signal and turn it off to demonstrate this is one push button. And now the sequence is at step 1. It's waiting for this sequence condition turn on. This condition will be controlled by other conditions. For example, sensor turn on, some cylinders at work or at home condition, right? Okay, so to test this sequence, I will manually turn it on. Once it's turned on, after 2 seconds, the sequence will move to the next step. And now we're at step 5. So if I turn on this step number condition 5, so it will move to the next step, step 10. And step 10 sequence is waiting for the conditions to turn this sequence conditions turn on. Okay, I will manually turn it on. It moved to the next step. Okay, sequence. Now we are at 15. So if this 15 turn on, it will move to the next step after 2 seconds. And now we are at step 20. Step 20, once this sequence condition 20 turn on, so the whole sequence will go to 0. And keep in mind, this sequence complete will turn on. It doesn't allow us to do this sequence again unless we remove the part. Okay, so if this condition turn on, let's watch it. After 2 seconds, the sequence are at 0. Now the sequence complete signal turn on. And let's move to the top. And because this sequence complete turn on, even if this sequence start turn on, the sequence will not start again by its own. Because this sequence complete turn on, this prevent our machine will do one part again and again. So until we release this part present, because when this part present turn off, so we will reset this sequence complete. Okay. So firstly, let me turn off this sequence start. So if we release this part present signal, okay, we will see this sequence complete signal turn off. So allow this signal is ready to allow this sequence is waiting for the new cycle start. Okay. So again, if we present this part present and it's waiting for the cycle start and waiting for this sequence start signal. So once we start this sequence start, again, so our sequence will move step by step. And because this time our sequence condition already turned on, we will see this sequence will quickly move one cycle and waiting for our released part. In actual case, those sequence conditions need to be controlled by other conditions. Okay, again, I will turn this off. And now we present the part, our sequence is at 0. Now if I start this sequence, it will move to number 1. And now number 1 is waiting for this sequence condition, move to the next step, turn it on. After 2 seconds, move to number 5 now. And waiting for this number 5 sequence condition. Now turn it on, it will move to the next after 2 seconds. Okay, let's turn this number 10 on, move to the next step. Okay, turn this 15 on. Okay, move to the 20. Okay, once we move to 20, once 20 done, so this sequence complete will turn on. So this sequence complete turn on. Okay. So it doesn't allow this sequence automatically start again. Okay, this is sequence structure. And in next video, I will demonstrate how can we use this sequence structure to implement the camera trigger to trigger the Keyence IV2 AI built-in camera. See you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.